Hi everyone, my name is Ajay Gunalan. I'm from Italian Institute of Technology and the University of Geneva. So here, I'm going to present about compressive image scanning microscope. And in order to understand compressive image scanning microscope, first let's understand what you mean by image scanning microscope. So if you look at this image here, this is our setup here. It is very similar to a standard confocal microscope. The key difference is instead of a normal detector, we have a SPAD array, and the SPAD array has like a 5 by 5 elements. And then because of this 5 by 5 elements, we have like a 25 parallel images generated. And the key idea here is to use this parallel images generated in order to improve the quality of the reconstruction. And then also like another problem is like using this galvanometers. If you want to do compressive sensing, usually people do like either people often utilizes DMDs or coded aperture, like where there is a binary mask, and then they use DMD or coded aperture to do the compressive sensing. But for example, in this application, you cannot do such kind of things because we have a galvanometer, and doing a random scanning with a galvanometer is like very difficult due to the dynamics of the mirror. So what we do here is like we have a sampling strategy, which is like a fixed one, where we skip the alternate rows and alternate columns. So all the black ones are like skipped points, and the white one is the sampled point. So thus we sample only 25% of the samples, and then by doing this we reduce the time of the acquisition, and also we reduce the photobleaching, and our results are like quite good compared to the normal setup. And this here we have compared the quality of the reconstruction images. And in the future directions, we want to focus on other stuffs like a block-based compressive sensing, where when you are acquiring the data on the top part, we want to reconstruct the bottom part. That is for this method. And then finally, right now it's implemented in MATLAB and Python. So next we want to implement on GPU, and we are also looking at other techniques to combine all the scanned images. So right now we are using something called the APR, which is adaptive pixel reassignment. But in the future we want to use deconvolution based methods, which will improve the quality much further. And that's all. Thank you for listening.